Okay, let's take a look at this problem here. We have two sinusoidal AC alternating currents, I1, which is given by this equation, and then we also have I2, which is given by this equation. Okay, and we're told to find their sum. Now, traditionally, if this was a purely math course, we can add the sums, the 4 cosine omega t and the 5 sine omega t, and add them using the identities that were defined previously. But that would take a long time. There's going to be a lot of computation involved in that. Okay, so what we want to do is we want to take a shortcut, and that's using the sinusoid phasor transformation. So you have this time domain, current, either sine or cosine, and we can just convert it to a phasor component here, where our our amplitude here is just going to be transferred over here, and then the angle is going to be transferred over here. Right? So let's take a look at what we have. So this is essentially the table that we're going to use to simplify this mathematical operation between the two currents. Okay, a couple other things I want to mention. I'll write them down as we go, but let's go ahead and start with the first one here. So we want to take current I1 and then put it in its phasor form. As you note, that current I1, it has the amplitude 4, it's cosine omega t plus 30. So this is the same form that we have here. So essentially all we got to do is we got to take the 4, okay, and the 30, and then just plug it into the IM and that there. So that's essentially what we're going to do for the first one. So I1, I1 of t, as we take it to I1 in its phasor format, okay, it's just going to be 4 30 degrees. Okay, so that's one part. The second part is you want to take I2, okay, and you want to put it in I2 format, okay, in its phasor format. Now we note that I2, we got 5 sine omega t minus 20. What we want to do is we want to take this I2 and put it in sine format, just so, put it in cosine format, or form, just to make this match up with the I sub 1. And to do that is to go from sine to cosine. So from going from sine to cosine, we just need to subtract 90 degrees. 90 degrees. Okay, so we're going to take I2 of t is equal to 5 cosine omega t minus 20 degrees minus 90 degrees. That's what we added to it here, and that's going to give us 5 cosine omega t minus 110 degrees. So this is the new current that we're dealing with, and now we're in this format where we can just take this 1, 5, and then minus 110, and use that to go to the phasor format. So now I2 is going to equal to 5 with an angle of 110 degrees. Okay, and we'll highlight that. So we got those two steps there. Now, essentially what we want to do is we want to add I1 and I2. So next step is to take, let's scroll up here. Now we want to do our I is going to be I1 plus I2. Okay, and that eventually is going to give us, when we convert back to time domain, I is equal to I1 plus I2. That's what we're trying to get to. Okay. So to do that, we just plug in the numbers. We got I1 is 4 angle 30 degrees plus 5 angle minus 110 degrees. Okay. But we can't simply add these guys here. We need to go back and utilize a couple things. And this right now is we are in polar format. Okay, we want to take it to rectangular format. So we want to convert to rectangular format and then bring it back into polar format to do the addition. So how do we do that? Remember that rectangular format where we define z as x plus jy. That's the rectangular format. And the polar is what we have here. This is where we're saying z is r some angle. Okay. In this case, rz is going to be the current. So for this problem, we're going to substitute the current for the z, but then xy. But the question is, how do I go from r to this here? Now we defined this previously. R is going to be, or x, let's go ahead and x is equal to r cosine the angle, and y is going to equal to r sine the angle. So we're going to utilize these conversions to take 4 angle 30 and 5 angle minus 110 to put it in rectangular format. So let's go ahead and take that step by step. Okay, so let's look at the first one. Let's break it down. 4 angle 30 degrees. I'm going to go, and this is technically our I1, right? So this is going to equal to x. Our r here is 4 cosine our angle, which is 30 degrees. If we plug that in the calculator, we get 3.464. Okay, and we're going to do the same thing for y. Again, it's going to be 4 sine 30 degrees, and that's going to give us 2. From here, we can write in rectangular formats our z1. I'm going to say z1, or in this case I1. I'll just use both of them here. Okay, is equal to 3.464 plus j2. Okay, we'll keep that there on the side. Let's scroll up a little bit, and let's do the same thing for I2, which was 5 at an angle of 110 degrees. We're going to follow the same steps. X equals 5 cosine minus 110 degrees. We plug that in, we get minus 1.71. We get y is 5 sine minus 110 degrees, and that's going to give us minus 4.698 to get to the third digit here. We add those to get the rectangular format. Again, this is technically our I2. I'm just going to call it Z2 here just to keep the notation similar, and I'll interchangeably do them just so you can see that. 1 minus 1.71 minus J 4.698. Okay, so again, this 3.464 is there, this minus 1.71 is here, this 2 is coming in here, this minus 4.69 is coming in here. Okay, but now we just want to sum those guys, so we can sum it because we're in rectangular format. So what I'm going to do is I'm just going to say my sum. Scroll up. It's going to say here, I'm going to say my I, or Z1 plus Z2, is equal to, and just sum them vertically, 1.754 minus J 2.698. 2.98. Okay. Now these rectangular formats, we want to convert it back into polar. So then from here, we want to go back to polar format. Okay, and to do that, we're going to use, let me go ahead and write it. To go from rectangular to polar, I'm going to use r equals x squared plus y squared, and our angle phi is going to be the tangent inverse of y over x. Okay, that's what I'm going to do to convert, and let's go ahead and write that down. So we got r equals the square root of 1.754 squared plus minus 2.698 squared, all that under the square root. We compute that, we get 3.218, and then our angle phi is going to equal to tangent inverse y over x, which is minus 2.698 over 1.754. We compute that, we get minus 56.97, so 56.97 degrees. Okay, so technically what that is our phasor there, so that's going to be our I is equal to 3.218 at an angle of minus 56.97 degrees. I'll highlight that here. And then finally, we got to take this guy and go to time domain. And that's going to be our sum. Okay, so we summed it up. That's what we got. So we gotta go to time domain, and to go to time domain, we just go back to this table up here, and we look when we have, in this case, we have our amplitude and our angle. We got our amplitude and our angle. We just gotta go back to this guy and just plug it into that cosine. Okay, so let's go ahead and do that. So to go to time domain, I of t, which is the sum of I1 and I2, is equal to 3.218 cosine omega t minus 56.97 degrees, and this is in amps, and this is our final answer here to get the sum. Okay, where this is 32, and this is, or 3.2, and this is that. Okay, so although this looked like a tedious process and a lot to do just to add I1 plus I2, but it's a lot simpler than the other route. Again, you see the math is very simple, nothing too complex. It's just a matter of following the proper steps to get to the sum of the current. Again, to summarize, we had the current in time domain, we converted it, so we had it in time domain here, here, we converted it to our frequency or phasor domain, and then we went from these polar formats to rectangular format. Okay, and then from there we added them up, and once we did that, we took those rectangular formats, switched it back to polar, because now we were able to sum them, and then from that phasor we switched it back to time domain, and we got the final answer. Okay.